Type in run there, hit enter. It's going now. Next thing I'm going to do is get into my interface mode by choosing an interface. And I'm going to choose E0 for Ether 0. Alright, now let's use our command CDP space. We're going to use the question mark again to see all possibilities for configuration in this mode. And there we go. The only one we have is the enable, which enables CDP on that specific interface. So let's do that. Enable and enter. That's as easy as it gets. But before we leave this configuration, let's go back to the two commands we had here, the hold time and the timer. Alright, so let me exit. When I type in exit at the prompt here, that is the configuration interface mode, it's going to take me up one level to the global configuration mode. From there I have these commands available to me, the hold time and the timer. Here it says the first one specifies the hold time in seconds to be sent in the packets. Most of the time Cisco gives you all the information you need to understand what this does. This one, maybe not. So let's go back to our slide, our whiteboard, and talk about that. If I have a hold time, what could that be? Alright. I have a router here and a router here. When information is sent from one router to the other, this hold time tells this router how long you can keep the information that I sent you in cache. In other words, I want to keep control of this information. You can only hold it for n number of seconds. That's the hold time. The other option we had was a timer. And all that's saying is, how often am I going to give you this information? So every, again, n number of seconds, I am going to send this out. And then that is programmable, as you saw on the router there, by the administrator. But there are default timers there, and we're going to talk about them when we talk about the communication overhead, and we're also going to talk about the importance of not changing those. And if you do, the caution that you need to have in mind when you do make those changes. So far in this nugget, we've talked about the purpose of CDP, and we've also looked at the ease of configuration. The next section is going to be a detailed look at the communications, or the overhead, that's caused by having CDP enabled on Cisco devices, and how that affects your network. Here we go. Let's look at the diagram we have first. We have two routers involved. The first is R2 for router 2, and the second is R3. In between the two, we have some device that enables connectivity to multiple devices on the same local area network. So this can be a hub or a switch. The importance here is that this whole area is the same broadcast domain, and we'll find out why as we look at the communication. Alright, the first thing we're going to discuss is advertisements. What happens is that one Cisco device is going to advertise its CDP information periodically over the wire. Alright, this advertisement is going to happen at predetermined amounts of time. Now the default is every 60 seconds. Okay, so every 60 seconds it's going to send a packet out. It does not expect a response. This is analogous to UDP. It sends it out there. It hopes that everybody that needs it on this wire gets it. But it's not going to double check, and all it's going to do is simply retransmit every 60 seconds in hopes that you get it. So there is no conversation, and there is no handshaking going on between the routers. So that saves in overhead. Okay? Now these advertisements go out, and the way they go out is in multicast format. Let's just discuss multicast for a while. We're probably very familiar with a unicast. That means a packet that is sent directly from R2 over to R3. It's the only person that this packet is destined for, the only device. And the way it knows that is from one specific MAC address to another. Recall from another nugget that MAC addresses are the layer 2 addressing. Okay, so at the data link layer. So that's unicast. The other option that you're probably familiar with is broadcast. It uses a MAC address of all Fs, entire Fs, and what that means is it is destined for every device within its broadcast domain in this local area network. So when all these packets, all these devices receive the packets, they will process the packet, and it wastes some CPU time. So what was the answer in between sending out individual unicast packets or a broadcast packet across the wire? The answer was the multicast. What it does is it uses a special address that we're going to see here momentarily, sends it out on the wire, and only people, or devices, that are participating in CDP will activate or do something with that packet. As it's received by these other devices, they'll simply discard it at layer 2 and throw it into the bit bucket. Okay? So it saves CPU time on each of these devices, because if it was a broadcast, they would each process that packet. Okay? And because it's a multicast, it doesn't require multiple packets to be sent out to every device on the wire. Let's say that we had another Cisco device connected here. So you had another router. If R2 wanted to communicate with R3 and R4 the same information, and you were using unicast packets, you'd have to send one packet out to R3, as we illustrated already, and another out to R4, which adds to our network overhead. So that's why multicast is the best solution for this particular protocol and what it's trying to accomplish. Remember I mentioned that we were going to look at hold down timers and the timers involved with the advertisements and understand the relationship between the two and the default settings. The default setting for the hold down timer is 180 seconds. Now this again is how long a device can hold information of another Cisco device in its cache. Cache is temporary memory. Alright, the relationship here is 60 to 80. There's no problem with the defaults. But let's take a look at, if we change the hold down timer to every 30 seconds, let's say, instead of 180. What happens is R2 sends out a packet to R3, and then it's going to wait 60 seconds to send it out again. Well, at 30 seconds, that information is timed out, so it no longer holds it in cache. So there's a 30-second interval there before the next advertisement is transmitted that we have no information on that specific neighbor. So CDP doesn't accomplish its task or its purpose with these two numbers and their relationship as it follows. Now let's take a look at the effect if we make this hold down timer longer than the default. Let's say 270 seconds. Here's what's going to happen. R2 is going to send out its initial advertisement out to a multicast address. R3 will be one of the devices that receive that advertisement. And it's going to say, I have an advertisement from device ID R2, which is the name of the router, and it's going to list a piece of information. We're going to get into more detail about each of these parts of information, but let's say for now, part of the capabilities list. It's going to say that that device is routing packets. Okay, so it is a router. And it also has bridging turned on. So it's actually a router, which is the combination of the bridge and the router. Alright, what happens? After that advertisement is sent out, the bridging functionality on R2 is turned off. So it's no longer supporting the bridging functionality. Alright? It's going to send out its advertisement again after 60 seconds has elapsed. When it sends that out, R3 is going to say, you know what? I have information cached for that device already, so I'm not going to accept the information. Therefore, not accepting the change. Okay? And so it's going to live with bad information, if you will, for a period of time. How long is that time? The hold down time. Because we made it longer, it is now going to wait 270 seconds before it allows for that change. So you want to leave it at the default. In fact, I can say that 99% of the time, the defaults will do for you. If you are in that 1%, then you can change these defaults. Just pay particular attention to the effect it's going to have on the information that you're gathering via CDP. Alright, we hit a little bit on the different pieces of information that are carried in those advertisements. And here they are. First part, the device ID. In other words, the name of the device. In this case, the name of this router is R2. There's going to be an address list, a port ID, a capabilities list, a platform, and it's also going to send out the hold down time. In other words, R2 is dictating how long R3 can hold these pieces of information in its cache. Alright, let's see that in action. We're going to take a detailed look at each packet that's sent across here, or each advertisement in this network, and we're going to do it by the use of a protocol analyzer. It's commonly referred to as a sniffer. Now, what a sniffer does is it sits on the network. Let's say we had the software installed on this PC, and it listens for all traffic going across this network, and it copies those packets, and it copies it for you to analyze, and it's going to have the detailed information at each level. In other words, the data link level, the network layer, the transport layer, every piece of information, whether it's a flag or data at each layer. Okay? Now, because we're on a switched environment here, the only access, or the only packets that we're going to see